Good morning, this is your Stat Sensei, Mr. Spensei, and this is the exit ticket, and it's based on our warm up where we went through the too cold to move scenario, and we filled in all the information from the table, and now we're going to define some of those in context. So the first thing it says, explain the slope in the context. Well, when we go up and look, we see slope is written as negative 0.00774, and we got that from the table right there. Now, one thing I like to do is I think it helps out a whole lot is to make that a fraction. All right. And remember, slope is the change in y over the change in x. So in this case, and by the way, when we do this for regression, we don't worry about decimals. We just leave it as that. So the y is going to be negative 0.07774 over 1. All right. Now, what was our explanatory variable? Our explanatory variable was temperature. And in the warm up, we said that it was the y was crawling age. We said that this was our response. All right, and that was our y. So we're going to put, so it's age, really it's crawling age, but age over temperature. So that's our fraction. All right, and once we have it written like that, it's pretty easy for us to go ahead and use the sentence stem. So there's a 0.0774 decrease, and the reason the word we're using here is decrease is because when I look at my slope, it happens to be negative. In crawling age, this is my y. For every 1 unit increase in average temperature, and average temperature happens to be my x. So there's a 0.0774 decrease. Now, if it had been positive, we would have said increase, but since it's negative, we say decrease in crawling age for every 1 unit increase in average temperature. The next thing it asks for is our correlation coefficient. And when we calculated our correlation coefficient, we said, hey, the slope is negative. So since the slope is negative, our correlation coefficient is negative. And we took the square root of r squared, and we'll do that real quickly here. We'll take the square root of the coefficient of determination, and we'll just divide that by 100 to turn it into a decimal and raise it to the half power. And we get 0.6997. Okay, so that's where that comes from. And the definition, there's a moderately strong negative. By the way, negative comes from the slope, moderately strong comes from that value right there. All right, remember we have a table of values, and this one happens to be a moderately strong. We always have to use the word linear relationship between crawling age. Well, this was the y, or our response variable, and this is our x. So here's our y, our response variable. This is x, which happened to be our explanatory variable, and it'll always be like that. The next thing we're supposed to do is the coefficient of determination. Well, we just said the coefficient of determination, which happens to be our r squared, is 48.96. So 48.96% of the variation in baby's crawling age. So in other words, in y, or the response variable, can be explained by changes in temperature, which happens to be our x. So here's crawling age, which is our y, and temperature, which is our x. Oop, that's wrong. That should have been highlighted in yellow. I got it. That's yellow. Age. Good. All right. So 48, the coefficient determination, which once again, I should point out is our R squared. So 48.96% of the variation in baby's age can be explained by changes in temperature. Lastly, interpret S. Well, S was the standard deviation of the residuals right here. That was our big S. The standard deviation of the residuals is 1.3192, and that's what we also marked right here. And it measures the variance in our response, our crawling age, which happens to be our Y, for a given temperature or a given temperature, excuse me. The standard deviation of the residuals is 1.3192, and it measures the variance in crawling age, which is our Y, for a given average temperature, which happens to be our X. All right, I hope this helps, and I certainly look forward to seeing you on the next one. Thank you.